What is data modeling? In this episode, I want to talk about what it is, the definition of this term, and why we talk about it so much in the functional programming community. My name is Eric Normand, and I help people thrive with functional programming. And I went outside today doing an old school season 1 style walk around episode. So if you're hearing some noise in the audio, that's what's going on. All right, so data modeling is something that we do in functional programming. Basically, with any kind of programming, you're dealing with some problem domain, some business problem, or it might not be a business, but it's some domain that you're trying to represent in the software, in the computer, in the memory of the computer. And depending on the paradigm, you'd use different parts of the language, different features of the language for representing those things. Data modeling just refers to representing those entities and concepts, their attributes, and the relationships between them using data, using just data structures, So in an object-oriented system, you would probably do an object-oriented modeling, where you would use a class to represent a concept, and then the class would have member variables, and those would represent like the attributes. And then you'd use references between the classes to represent the relationships. And there's so that would be like a has-a or a has-many relationship. That's a very standard way of representing a domain using classes in an object-oriented language. We don't do that in functional programming. What we tend to do is just represent it as data. And if you're using a typed language like Haskell, you would define new data types that have the attributes and relationships you need built in. But if you're using something like Clojure, we tend to use the built-in data structures like the hash maps and vectors and things to represent those attributes. Now, what becomes interesting is very often in a problem, the relationships are more important than the entities. Okay, so the entities kind of are important, but they're not as important as the relationships. So in those cases, you're probably better off making that relationship first class. So let me give an example. I could have an entity, let me say, let's say I want to build a graph. Okay, and so I have the nodes are my entities, and then the edges between the nodes, I could represent those as pointers. Right, so I go to a node, and if it's, this could be in OO, could be in functional, doesn't matter. I have some pointer to another node. So the node has like a list of other nodes it is connected to. And so I can walk this graph, right? But what if I invert that? And what if I say, I'm going to keep a list of all the edges? So I'll keep an edge would be let's say it's just a tuple of, edge or node A to node B, right? So it becomes a pair. It's a directed graph, so I could have both ways, but they're represented separately. I'd say, here's a list of all of the edges. Because in that case, the relationship, the edge, is what's important. If it is important, that's the way I would want to represent it. So now I can count edges really easily. And I can do stuff like, with a single, walk through that list, I can create an index of, give me all the things that A is pointing to, give me all the things that B is pointing to, all the things that C is pointing to. I can make an index of those. And also the reverse index. And make that one too. Instead of seeing the graph as pointers that I have to walk between. Right? So this is the kind of thinking that we do in data modeling. How can I represent this domain of graphs, in a way that will allow me to do what I need to do, with my algorithms. That's basically all it is. Now in functional programming, we tend to, in opposition to object-oriented programming, we tend to keep our data separate from the functions, from the behavior. And that gives us a tremendous amount of flexibility, because there's no thing called a node anymore where the methods go. I don't know if it's a psychological thing or mental thing, but when you start making a hierarchical ontology of graphs in your type system or in your class inheritance system, in my experience, I get stuck. I just, I can't do these mental manipulations anymore. I've got this class called node. I've already added 10 methods to it. I can no longer think of, a graph is just a collection of edges. I still see it as a graph is nodes connected with references. It just makes it a lot harder to switch the way I see it. Whereas I find with data modeling, I see it in a different way. It's like if I started with nodes as primary and had edges secondary, but I have an algorithm that needs the edges primary, I just think of it, I just need to create a function that transforms a node first, node primary representation into an edge first representation. And then I'll have what I need. So I guess I see it as an advantage. You start to think more flexibly. It's just my opinion, it's my experience, but it's what I see. All right, so this has been me talking about data modeling, why we do it as functional programmers, what it is, how you're probably doing it too already. But that's what we do. We take a problem domain and we represent it as data so that we can run algorithms on it. It's pretty simple. Awesome. This has been my thought on functional programming. I'm Eric Normand, and you can find this episode and past episodes at lispcast.com/podcast. You'll also find links to subscribe and to my social media. I love getting in touch with people. I love having people ask me questions, get into discussions. If you agree or disagree, please get in touch with me in the best medium for that particular question. You be the judge. No need to ask me how best to get in touch with me. If you think Twitter is the right place, let's do it on Twitter. No problem. Okay, awesome. See you later. Bye.